Math time.
Kobe.
This part of my body is called what?
Hand.
Excellent. Everyone agree? No.
Hand.
This is a hand, yes?
Yep.
What is the surface area of my hand? Can you measure it accurately?
No.
No. But how many hands is that?
One.
One. So this has a surface area of one hand. Do you agree?
Yes.
Does everyone agree?
Sure.
This is one hand.
Sure.
You say that's more than one hand? I'm some kind of mutant? This is a hand, yes?
Yeah.
Excellent. What's this?
Another hand.
Another
An
hand.
arm.
What is this hand surface area?
One hand.
One hand, yes?
An arm.
So if this is one hand and this is one hand, what is the surface area when I put them together? Wrong. Why?
One hand.
Wrong. Why?
Three hands.
Wrong. Why?
Put them together. One.
Wrong.
None. Negative.
What should it be?
Should be one. Two.
It should be two. One hand, right? If I dip this hand in paint, it's all going to get covered, yeah?
No.
Sure it will.
Your fingers are together.
Yeah, but this whole area will be covered, yeah?
Not in there.
No, but this whole area will be covered. You guys said this was one hand.
Yeah.
If I dip this hand in paint, will it be covered?
Yeah.
That would be two hands, yes? But if I do this, what happens?
Four hands.
No.
One hand. One whole hand.
Is that going to get covered in paint?
Oh.
hand. So
It's going to lose some area once I put it together, yes?
No.
So, I'm going to lose this much of this hand and this much of this hand, yes?
yeah.
So it is two hands minus this much how many times? Twice. Right? Now, if that happens in once in math, how often will it happen? Always. So, if I take this box, does it have a surface area? Yes. If I dip it in paint, it will be completely covered. Agreed?
Yeah, I agree.
And then I take this rectangle, this rectangular prism, and I dip it in paint. Will it be covered?
Yeah.
So it will be this surface area. We'll call this surface area A, right? Plus surface area B, right?
Yeah.
But if I do that,
It's one.
I lose this much how many times? Twice. I lose it on here and here. Got it? Confusing?
No.
No. And yet, overlaps are very confusing to everybody for some reason. So, let us look at what we have here. Here I have a pretend object made of centimeter cubes. First thing we're going to do is we're going to draw it. What does the front of that look like? 3 boxes. I've given you the paper with which to draw it. Draw it. There's the front. Do we agree?
Yes, sir.
If it's got a front, what must it also have? A back. Does everyone agree that that is the front and back? Front and back. Cool? So what is the surface area of the front and the back?
6, 3, 6,
Which is it, Riley?
3. Of both, like together?
I want the surface area of the front and back.
Oh, then it's 6.
6. Right? Okay. Now I want to do the side. What does the side of this thing look like?
Just the same thing.
It would be 2, yeah? If there's one side, what is there on the other side?
The thing.
The exact same thing.
That's the front.
So what is the surface area of the side? 4. 1, 2, 3, 4. What does the top of it look like, which would be looking straight down? 2 boxes. If there's a top, what is there? A bottom. Making what? 4. Does everyone agree? Right? So, front and back we found to be what? 6. Top and bottom we found to be what? Right and left we found to be what? 4. Agreed?
Yes.
What are you going to do with those numbers? Add them up to get 14. Is everybody cool?
Hold up, that's slow it up.
Does this you three are definitely the three that shouldn't be paying attention to this because you all get 100% on all your tests, right? Right? No. Oh, I'm sorry, I forgot. You don't get 100% on all your tests. But you pass them all, right? Oh, crap, I forgot that. You don't do that either. Damn. Maybe I should shut my pie hole and listen. Was that complicated?
No.
Can you all count?
Yeah.
Of course you can. If I then... I'm not going to give you graph paper all the time, mostly because most of you won't do it right. But what I'm going to do is this. Everybody draw yourself a cube. If you cannot draw a cube, actually, I will show you how to do it easily. Draw a square, go up and to the right, draw just the L, and connect the corners.
That's not a square.
Okay? Now, if this is 1, and this is 1, and this is 1, then what's this thing's surface area?
1.
No.
1 times.
1 times 1 is 1, and there's 6 of them, right?
Oh, it's the whole thing.
The whole thing is 6, agreed?
Yeah.
How many of these cubes made up our shape?
6? Wait, no.
1,
1, 2, 3,
Oh, yeah.
right? Everybody agree? So 3 of them, it would be 6 times 3. It should be 18, shouldn't it? But what happens right here? There's an overlap, yes? So I lose every overlap how many times? I lose every overlap twice, right? I lose it once on each shape. So the 18, I'm going to lose 2, because there's going to be an overlap there, yeah? And then there's another overlap where? Right here, right? Oops, that should be white. Right here, yeah? There's that overlap. How many times do I lose it? Twice. So I'm going to lose another 2. 18 minus 2 minus 2 is 14. Can you see how we get the same answer? Whether we count it by actually counting the faces or by doing logical math. Can we all do both of these? I should hope so. There's your first example. If you don't wish to draw it, you feel you can just do it with the numbers, try it with just the numbers. If you feel you need to draw it, draw it. I don't care. Your call. I'm going to draw it. And I'm going to outline each face that I draw in the color that I am drawing it.
What's the bar? What's the bar?
The blue one, and then the right and left, they're a little bit harder to see.
What's the bar?
So I'll outline them in white.
Put the bird.
18. Got it? Everybody able to do it that way?
Yep.
Now, it makes sense, doesn't it? Because this guy, if he was by himself, would be 6, wouldn't it? So there would be 6 times how many?
4.
6 times 4. 6 times 4 would be 24. But there's an overlap here, yes? So that overlap would cost us 2, correct? There's an overlap here. That overlap will cost us how much? Minus 2 more. And there's an overlap here, and that overlap will cost us how much? 2. Minus all the overlaps, and I get the same number. Is everybody good? Yes?
Yeah.
Okay. Now, let's actually make this slightly more difficult. A composite object, that's a new word. You've been watching it all day up on the board. Composite shapes. A composite object is formed from 2 or more other objects. Okay? You guys already know those objects, right? There's prisms. And prisms are either, for us, rectangular or triangular. In grade 9, there's only rectangle and triangle prisms. We don't go any further. Okay? Pyramids, cones. Okay, everybody cool? All right. There is also cylinders, which we remember are technically what? It's technically a rectangle and 2 circles, right? So a cylinder is technically a circular prism, isn't it? Because it's 2 circles separated by a rectangle, right? So is everybody cool? So a composite object puts at least 2 of these things together. So 2 cylinders, a cylinder and a prism, a cylinder and a triangular prism, so on and so on and so on. Is everybody cool? As long as you have 2 together, you have a composite object. Okay?
Yeah.
All right. So this is what we were talking about right now. If you draw a rectangular prism, draw a rectangle, draw the L, connect the dots. You can all draw that, right? And its surface area would be all this yellow, correct? And you guys could work that out. 2WH, WL, and LH, right? We know how to do that when there's one shape. Because we've already done it, right? We have a whole page on it. Everybody cool? We would follow the formula. 2WH plus HL plus LW, and we'd fill it in and we'd be good, right? This would be W, this would be L, this would be H. And we could fill that formula and we get the answer, correct? Now, if I then drew a cylinder over here, and to draw a cylinder, draw a circle, 2 lines off it, and then half a circle, that guy would be what? 2 pi r squared plus 2 pi r h, correct? Are either of those composite figures yet? No. What if I put them together? Okay, so if I put them together, this shape is going to move over and be stuck on there, yeah? Everyone agree? So if that shape moves over there, what happens to that shape's surface area? It must move over there too. And what math would we use to put them together? Add, correct? But there's a problem now. 1 hand, 2 hands. What happened? Overlap. How many do we have to take away? 2 of them. So here there's an overlap, isn't there?
Yeah.
So what is that overlap in this case? What shape is it? Minus 2 overlaps. And in this case, the overlaps are a circle. Everyone with me? Now, be smart here. What is the formula for the area of a circle? No, just pi r squared. But there's 2 overlaps, right? So I'm really subtracting 2 pi r squareds, aren't I? Look in my formula. Do you see a 2 pi r squared there somewhere? Right there, yeah? So if I'm subtracting that, what can I do with that? I can cancel it right out, just like we did in algebra tiles, which are totally useless, remember?
Yeah.
Except they're not. Because if you remember that concept, you can use it right here. And then what's the only math you have to do? This and the curved edge. You don't have to worry about overlaps. See what I'm saying? If you show your work, you can actually save yourself work. Okay? Do you have to do it this way? Of course not. You can write it all out and subtract 2 overlaps. I don't care. That's up to you guys. Understand?
Yes.
So the point we were trying to make, the overlap is not painted, so it's not part of the surface area. That's easy to understand, right? Because the overlap can't get covered in paint. But what we have to remember is we must subtract 2 areas of overlap for every spot that shapes touch. And here's what I mean by that. This drawing right here, I've got an overlap here, right? This circle. So I take away 2 circles. Agreed? Everyone agree? But what if I make this a barbell? Now how many overlaps do I have to take away? 4. Because there's 2 spots where it's touching and each overlap removes 2 areas. Do you get it? Picking up what I'm putting down? Okay. Let's see if you can figure it out. We're going to do this one 2 ways. We're going to do this the long way, then we're going to do it a shorter way. Everybody good? Okay. So the first thing we're going to do is the long way. This way, ladies and gentlemen, will always work. Always. It will take longer, but you can't do it wrong. Always. It's surface area of shape 1 plus surface area of shape 2 minus 2 overlaps will get you your surface area total. Does everybody understand that?
Yes.
Okay. So which of these is smaller? This guy or this guy? This guy down here, yeah? Front, back, left, right. They're all going to be the same because this is 6 and 6. Cool? So the front, back, left, and right are all a rectangle that is 3 by 6, correct? And how many of them are there? 2. Front, back, left, right. 4. So that is 4 times 18, which is 72. Does everybody understand that? Yeah? Okay. What are the front, top, and bottom? There's 2 of them, and how big are they? Pardon? 6 by 6. And there's 2 of them, so it's 2 times 36, which is 72. Does everyone agree? What do I do with those 2 numbers now? Add them up. 72 and 72 is 144. Is everybody cool? So surface area of shape 1 is 144. Everybody good? Okay. Surface area shape 2. You guys should go ahead and be able to do this but on your own now. Front, back, top, bottom. What are they? It's a rectangle. How big is it? 6 by 12. And there's 4 of them, right? 12 by 6 is 72. 4 times 72 is 288. Is everybody cool? I'm doing this in my head. You would be using a calculator, but you can all find 288 there, yeah? Okay. And what are the top or right and left? 6 by 6. There's 2 of them. 2 times 36 is 72. Add it up. 360. Agreed? Is everybody still okay? So now I would go up here, and I know my second one is 360. Then all I got to talk about is my overlap. Where is my overlap? It's right here, yeah? Right? So I come down here, and it's the 3 by 6, correct? 3 by 6 is 18. So minus 2 overlaps. My overlap was 18. So it's minus 36. And then you'd be in business, correct? Is everybody good? So 144 plus 360 minus 36 is 468. Is everybody good? Okay, now I'm going to show you something that will require you to understand more math, but do less work. You with me? Okay. I'm going to take my blue highlighter and I'm going to highlight the big prism. Is everybody with me? So we all agree that this part is part of the big prism, yeah? Right? And this part is part of the big prism, yeah?
Yup.
And this part is part of the big prism, yeah?
Yup.
Where else?
Bottom.
That is part of the big prism, isn't it, Riley?
Yes.
Does everyone see that?
Oh, yeah.
This blue part, if this wasn't here, would this be part of this?
Yeah.
Excellent. So what I have there is really a rectangle prism in blue, right? Which would be 2 LW WH and LH, correct? And then what did I add? I added this part and this part, correct? Times 2 and times 2. Then do I need to worry about overlaps?
No.
No. So I'm actually doing less work, aren't I? Okay? Because this blue part was already counted in the big blue part. So I don't have to worry about overlaps. Because the mistake that you guys make is you forget to take away 2 overlaps. So I like to do this algebraically. The big one, and then I add 2 of the roof, 2 LWs there, plus 2 LWs there. And then I'm actually doing less calculations. But to do that, you have to understand what's going on. Picking up what I'm putting down? Okay. You guys try this one. Now, please notice it's extremely easy because it's only asking you to do the last step, isn't it? Because what does that say and what does that say? Those are already the surface areas. Do you even need to work it out? No. But you do need to know the overlap, which is how big? 3 by 1. 3 by 1 is 3. Then all I have to do is remember, every composite object is shape plus shape plus shape plus shape minus 2 what? Overlaps for every overlap that happens. So I had 70 for the big guy. Oh, wait, the smaller prism. They write the smaller one first. 40 plus 70 minus 2 overlaps. What was my overlap? 3. So it's 40 plus 70 is 110 minus 6 is 104. Can everybody do this?
I think so.
This is really easy when it's 2 rectangles, yeah?
No.
Okay. See if you can do it. Go to this one. Now, again, please notice how much blank space I've given you on this piece of paper. If you wish to do this algebraically, by all means, write it out here. If you wish to use the charts, because you're better with it as a picture, write it out here. I don't care. I'm going to do both. Okay? Go. Yeah?
I know. People shop his abs on his music video.
So mine is done the long way. Algebraically, it would be this. 2, I lie, because it's a cube, I would say it's 6 LW plus 4 LW. Because I don't need all 6 of these guys, do I? Right? So 6 times 6 by 6 plus 4 times 2 by 2, correct? So that is 216 plus 16, right? 2 times 2 is 4 times 4 is 16. Yeah? Minus 2 times 4. 216 plus 16 is 232. And I got the same thing in both. Is everybody good? We are stopping there because rectangles are the easy ones. Go back to your work, your textbook, and do page 30. Do it all because you guys are bad at this. Okay? So that's for the rest of the day. You're working on that. It's only 10 minutes. That's your homework for tonight. Tomorrow, your quiz will be up to here. Your first quiz. Nothing that's doubled early. Because the quiz has nothing that's a composite. Okay? That's what your quiz will be. Tomorrow, we'll do composite shapes 2. We'll do a quiz on composites. Then we'll do our review. And we'll see where we are. Okay? Everybody good?
Yeah.
All right. Go.
Piece the scene. Someone want a saucy and piece to the least.
Dorian Leeson.
Pouring in the house.